I have found in my research of the ways that our perception of plane versus planet has been manipulated, and other findings of interest in this video. One viewer suggested I do this for a short and sweet, and others want to know my views specifically about the subject. I have already done most of the research that follows, and it does not take me long to put together when that is the case, so I can get it out more quickly compared to brand new research, which takes a lot more time to produce. A lot of what I have discovered about this subject was in my research of cities and places in long-distance alignments, based on and emanating from my finding of the North American star tetrahedron in 2016, which is where my original research on this subject began almost 6 years ago. My name is Michelle Gibson. My own journey into researching the whole of this started with the data points I have on spreadsheets in the form of cities and places in alignment with each other, and for which I have come to believe Earth's original ancient civilization was laid out according to sacred geometry, also aligning heaven and earth. It is helpful to define some terms used to describe how the Earth has been measured and mapped in the present day and in the past. The study of geodesy is defined as the science of accurately measuring and understanding the Earth's shape, orientation in space, and gravitational field. A geodetic system is a coordinate system and a set of reference points used for locating places on the Earth. A geographic coordinate system enables every location on Earth to be specified by a set of numbers, letters, and symbols. The coordinates are such that one of the numbers represents a vertical position, which would derive from the north-south lines of latitude, and the horizontal position from the east-west lines of longitude. Longitude fixes the location of a place on Earth east or west of a north-south zero line of longitude called the prime meridian, to plus 180 degrees westward and minus 180 degrees eastward. Sir George Bedell Airy, an English mathematician and astronomer, was the 7th Astronomer Royal from 1835 to 1881. He established the new prime meridian of the Earth in 1851 at the Royal Observatory of Greenwich in London, and by 1884, over two-thirds of all ships and tonnage used it as the reference meridian on their charts and maps. In October of 1884, the United States hosted the International Meridian Conference, attended by 25 countries, in order to determine the prime meridian for international use, after worldwide pressure had been applied to establish a prime meridian for worldwide navigation purposes and to unify local times for railway timetables, with Sir George Bedell Airy's Greenwich Meridian already being the favored one for use. 22 of the 25 countries in attendance voted to adopt the longitude of the Royal Observatory in Greenwich as the zero reference line. Interesting to note, the International Meridian Conference was held right before the German Chancellor Otto von Bismarck organized Berlin Conference, which was convened in November of 1884 and lasted until February of 1885, during which time almost all of Africa was carved up between the European powers. The prime meridian of the Earth, previous to the Royal Observatory of Greenwich, was the Great Pyramid of Giza, located at the exact center of the Earth's landmass. Karl Munk deciphers a shared mathematical code in his book, The Code, related to the Great Pyramid and the dimensions of the architecture of sacred sites all over the Earth, one which encodes longitude and latitude of each that cross-reference other sites. He shows that this pyramid code is clearly sophisticated and intentional, and perfectly aligned over long distances. I just recently learned about the National Geodesics Survey, or NGS, and its transcontinental leveling program that started in 1887 in the research for my last short and sweet video. The National Geodesics Survey was the first civilian scientific agency established in 1807 by President Thomas Jefferson as the Survey of the Coast, with a stated mission to survey the U.S. coastline and create a survey network, establish coastal water depths, and nautical charts to help increase maritime safety. This was a sketch of the New York harbor showing the first fieldwork of the Survey of the Coast in 1816 and 1817. Today, the survey network, first established in the early 19th century, is called the National Spatial Reference System, or NSRS, for surveying and engineering projects requiring precise spatial information, and has been administered by the National Oceanic and Atmospheric Administration of the U.S. Department of Commerce since 1970. The National Geodetic Survey started a transcontinental leveling program in 1887, with leveling defined as a high order of accuracy, usually extended over large areas, to furnish accurate vertical control for all surveying and mapping operations. They utilized horizontal datum, benchmarks made typically of brass, bronze, or an aluminum disc set in concrete or rock, assigned precise latitude and longitude measurements within the survey network. I know there is a lot more to unpack here, but I find this very interesting in light of what horizontal and vertical mean and the implications in relationship to the shape of the Earth's surface. Daylight savings time apparently was first proposed by George Hudson, an astronomer and entomologist, or studier of insects, from New Zealand. In 1895, he presented a paper to the Wellington Philosophical Society proposing a 2-hour daylight saving shift because he wanted more daylight hours in the summer to pursue his collecting of insects. The other person who was credited with independently coming up with the daylight savings time concept was English builder and outdoorsman William Willett, proposed the idea to Parliament in 1908, though the bill failed to pass after multiple attempts until 1916. Also of interest to note, the Global Positioning System, or GPS, was developed by the United States Department of Defense and launched for military use in 1973 and became fully operational in 1995. Civilian use was allowed starting in the 1980s. It was based on ground-based radio navigation systems that were developed in the early 1940s, like LORAN and Decca Navigator. For point of information, this is the image found on the NASA Space Place, Science for Kids, about how does GPS work, and is typical of the visual imagery that is available to us on this subject. Now onto the subject of early maps and globes. In earlier maps, ley lines were depicted on land and sea, like on the Catalan Atlas of the Majorcan Cartographic School, considered the most important map of the medieval period in the Catalan language, dated to 1375. Here's a map of Africa's Gold Coast showing ley lines as well. And another early map was the Cantino planisphere, said to have been completed by an anonymous Portuguese cartographer sometime before 1502. A planisphere is defined as a map formed by the projection of a sphere or part of a sphere on a plane. What we are told is that in cartography, the science of map making, a map projection is a way of flattening the globe's surface into a plane in order to make it into a map, which requires a systematic transformation of the latitudes and longitudes of locations from the surface of the globe into locations on a plane. It would seem that the Earth's ley lines started to disappear from maps in the 1500s when Gerardus Mercator, a Flemish geographer, cartographer, and cosmographer, published a world map in 1569 that is considered to be the first where sailing courses on the sphere were mapped to the plane map, allowing for a correction of the chart to be more useful for sailors. His 1569 map showed the depiction of straight ley lines in the seas. Here is a close-up section of the 1569 map showing the depiction of straight ley lines in the seas, but not on land and sea, as were present on the flat projections of the Cantino planisphere, the Catalan Atlas, and the African Gold Coast map. Not only that, Mercator was also a globe maker, like this one from 1541. Ptolemy's geography was an atlas and treatise of geography from 150 AD, said to compile the geographical knowledge of the 2nd century Roman Empire, and a revision of the now lost Atlas of Marinus of Ty, a Phoenician cartographer and mathematician who was said to have founded mathematical geography and who introduced improvements to the construction of maps and developed a system of nautical charts. This is the cover of Mercator's 1578 publication of Tabulae Geographicae, along with the globe, and Ptolemy said to be depicted on the left, and Marinus of Tyre on the right. Notice the difference between the lines on the globe at the top of the engraving and the globe at the bottom, and while Ptolemy is pointing down to the globe at the bottom, he is holding up a geometric shape in his right hand that looks like the lines on the globe at the top on the left, which looks remarkably like the shape the sacred hoops form in the Native American hoop dance on the right. We are told the first globe in existence was called the Erd